Welcome aboard, where aviation concepts become simple. From instruments to aerodynamics, we make exam prep clear and cockpit learning faster. This is StudyKwik Aviation.
Welcome to StudyKwik. Today we explore altimeter errors: instrument, pressure, position, maneuver, lag, barometric, and temperature. Instrument error comes from friction or imperfections. It increases with altitude, especially in sensitive altimeters. Position error happens due to airflow turbulence near static vents. Designers reduce it with extra vents on both fuselage sides or with combined pitot-static heads in high-speed aircraft. Calibration is key. Instrument error is checked in workshops and pressure error during flight trials. A correction card shows adjustments. Example, if you need 4,000 feet, but correction is -50, the altimeter will indicate 4,050 feet. Modern aircraft solve this with air data computers. Maneuver error occurs during pitch or yaw. Pressure shifts make readings unstable. Yaw has more impact when static vents are used. Time lag error is the delay in altimeter response. It underreads while climbing and overreads while descending. Servo altimeters fix this under normal climb and descent. So far, these are design-related errors, but external errors are bigger: barometric and temperature. Barometric error occurs if the altimeter setting doesn't match local pressure. Even 1 hectopascal equals about 27 feet of error. Example: altimeter set to 1013 HPA. Sea level pressure is 1003. At 4,000 feet indicated, true altitude is only 3,700 feet. Temperature error happens because altimeters assume ISA lapse rate. Colder than standard air makes them overread. Warmer air makes them underread. That's why temperature checks are vital near terrain or clouds. Barometric error can be huge. Example: QNH, 1025 hectopascals indicated 3,500 feet. Airfield QFE is 985 hectopascals. That's 40 hectopascal difference equals 1,200 feet. So actual height above the airfield is only 2,300 feet. Temperature error reminder: cold air, true altitude lower than indicated. Warm air, true altitude higher. Flying from warm to cold, the altimeter overreads. Cold kills. Flying cold to warm, the altimeter underreads. Corrections can be made 3 ways: formula, navigation computer, and tables for decision height. Formula example: indicated altitude is 20,000 feet. Outside temp is -35 Celsius. ISA at 20,000 feet is -25 Celsius. Correction equals -10 times 80 equals -800. True altitude equals 20,000 minus 800 equals 19,200 feet. The navigation computer indicated an altitude of 20,000 feet against an actual temperature of -35 degrees Celsius. The outer scale then shows a true altitude of 19,200 feet. The table method is used during approaches for correcting decision height or altitude. For example, a decision height of 400 feet in -40 degrees Celsius conditions gives a correction of 80 feet, making the indicated flight level effectively 480 feet. Let's summarize the errors we have covered so far: instrument error, position or pressure error, maneuver-induced error, and lag. These errors can be corrected using calibration cards or by modern air data computers. Now, barometric error: always keep the QNH updated and correct. Otherwise, the altimeter will either overread or underread. Temperature error is another important one. It can be corrected using a formula, a navigation computer, or tables. This correction is essential for determining true altitude and for maintaining safe flight levels. Remember, corrections only apply when flying for true altitude. If flying at pressure levels with QNH set to 1013, no temperature correction is applied, and the altimeter only shows pressure altitude. That wraps up altimeter errors and corrections. Now let's move to blockages and leaks in the static system. If the static source is blocked, the altimeter freezes at the altitude where the blockage occurred. During a climb, this causes the altimeter to underread. During a descent, it causes an overread. If there is a static line leak, the effect depends on the leak location. Outside the pressure hull or in an unpressurized area causes the altimeter to show a small overread. Inside a pressurized compartment makes the altimeter show cabin altitude, making it completely unreliable. Altimeter pressure problems are common, so let's take a practical example. Suppose QNH is 1,025 hectopascals, the aircraft is at 3,500 feet, and the airfield QFE is 985 hectopascals. The difference is 40 hectopascals, equal to about 1,200 feet. So the true height is 3,500 minus 1,200, giving 2,300 feet above the airfield.